tautomerism. So it is a special kind of functional isomerism in which the isomers exist in dynamic equilibrium with each other. It arises due to migration of a hydrogen atom from one polyvalent atom to the other within the same molecule with necessary rearrangement of linkages. The isomers thus obtained are called tautomers, and the phenomenon is called tautomerism. Tautomerism is called desmotropism. Desmos means bonds, propose means turn. Types. Tautomerism is of several types. The two important types are diet system and second is the triad systems. First one is the diet system. This type of tautomerism involves 1-2 migration of a proton from one polyvalent atom to the other within the same molecule with necessary rearrangement of linkages. For example, hydrogen cyanide. So इधर जो हाइड्रोजन अब नाइट्रोजन के साथ अटैच्ड होगा, राइट. सो ये हाइड्रोजन साइनाइड, दिस इज द हाइड्रोजन आइसोसाइनाइड. Here hydrogen migrates from carbon to nitrogen. The alkyl derivatives of these tautomers are called cyanide 1 and isocyanide, right? So these are the alkyl sign. So अगर इसके साथ अगर alkyl जोड़ दिया जाए, so ये alkyl cyanide और दूसरा ये alkyl isocyanide. So it may however be noted that although hydrogen cyanide and hydrogen isocyanide are tautomers, alkyl cyanide and alkyl isocyanides are not tautomers but are simply functional isomers. So ये दोनों जो हैं ये simply functional isomers हैं, but not tautomers. That is simply the migration of a proton. Then next is the triad system. So there are many types of triad system. In all these systems, hydrogen migrates from one polyvalent atom to the third polyvalent atom within the same molecule. Keto-enol tautomerism is just one type of triad system. So in this type of tautomerism, one form tautomer contains the keto group and while the other contains the enolic group. Three simplest examples of keto-enol tautomerism are acetaldehyde, acetone and cyclohexanone. So ये CH3 C double bond OH, ये acetaldehyde. Keto form, which is almost about 100%. So इसका जो enolic form है वो बहुत less, that is very less. Vinyl alcohol, this is the enolic form, so it is very less. Then is the acetone. Keto form. So ये भी कीटोन में ज़्यादा रहता है, CH2 डबल बॉन्ड C OH CH3. So it's a 1 into ol. So it is the enolic form. So it is again very less, negligible. Then is the cyclohexanone. Cyclohex 1 in 1 ol. So this is 98.8%, this is 1.2%. So in all the monocarbonyl compounds listed above, the greater stability of the keto form with respect to enol form is due to the greater strength of the carbon oxygen pi bond. That is 364 kilojoule per mole as compared to carbon-carbon pi bond, which is 254 kilojoule per mole. Then the factors affecting the relative amounts of keto and enol forms in keto-enol tautomerism. The following three factors affect the position of equilibrium in keto-enol tautomerism. First one is the stability of the enol form. As stated above in simple aldehydes and ketones, aldehyde acetone, the amount of enolic form is negligibly small. However, if the enolic form is stabilized by intramolecular hydrogen bonding, chelation or resonance, such as in 1,3-dicarbonyl compound, the amount of enolic form is much greater than in aldehyde or acetone. For example, in acetic ester, the amount of enolic form is 7%. So ये है acetic ester. So 1,3-dicarbonyl compounds, so which has the keto form 93%. So ये dicarbonyl, दो कार्बोनाइल ग्रुप. So ये स्टेबल क्यों है? बिकॉज ऑफ हाइड्रोजन बॉन्डिंग, दिस और दिस. So similarly, acetyl acetone